Hi everyone, I am Mr. Franklin P. Calaminos, a Doctor of Philosophy, Mathematics Education student of Sorsogon State University School of Graduate Studies. And I'm going to discuss one of the topics in modern geometry, the well-known Euclid's postulates. To start with, let's get to know first Euclid of Alexandria. He was a Greek mathematician and geometrician born in Alexandria in the 330 BC. His best-known work is Elements, which contains significant themes related to geometry and arithmetic. He is known as the father of geometry for his great contributions to the world of geometry and mathematics. As to Euclid's discoveries, he made several important discoveries in the theory of numbers, as his well-known algorithm for the calculation of the maximum common divisor of two numbers, in the field of geometry with its axioms and the set of books that make up the work entitled Elements. As to his contributions, his work includes several contributions that have been of great importance for the development of the study of geometry. These are 1. The elements, 2. The Euclidean algorithm, 3. The Euclidean geometry, the mathematics and demonstration, and lastly, the axiomatic methods. Okay, so the elements is the Euclid's best known contribution, and it is made up of 465 propositions, 93 problems, and 372 theorems that include the most important mathematical and geometric developments of his time. In this work, we find the 5 Euclidean postulates, which will be discussed on the succeeding slides, and the Euclidean algorithm. Now, the books from 1 to 6 develop themes of flat geometry. The books from 7 to 10 deal with topics of arithmetic by presenting the theory of numbers and irrational segments. Then the books from 11 to 13 explain spatial geometry. Now let's talk about Euclidean algorithm. In this algorithm, Euclid describes the method for finding the greatest common divisor, or the GCD, between two numbers. This work has been of great importance to mathematics and has been applied in other fields such as economics. So let's have some examples in which we're going to find the greatest common factor, or the greatest common divisor, using the Euclidean algorithm. Now, on the first example, we are tasked to find the greatest common divisor of 12 and 30. So 30 divided by 12, that is equal to 2, remainder 6. And we're going to divide the divisor 12 by the remainder 6. And that results to 2, remainder 0. And with that, the greatest common divisor is 6, given the numbers 12 and 30. Now, let's have the second example. Find the greatest common divisor of 123 and 36. So dividing 123 by 36, so that results to 3, remainder 15. Then 36 will be divided by 15, and that results to 2, remainder 6. Then on the next part of the solution, we'll be dividing 15 by 6, and that results to 2, remainder 3. Then 6 is to be divided by 3, then the quotient is 2, and has a remainder of 0. So with that, the greatest common divisor of 123 and 36 is 3. So that is how we find the greatest common factor and the greatest common divisor using the Euclidean algorithm. Okay, so what is Euclidean geometry? So the contributions developed by Euclid in the field of geometry have dominated the study of this science for almost 2 millennia, especially in the areas of flat geometry and spatial geometry. Now, Euclidean geometry, besides being a valuable tool for deductive reasoning, it has been used in other fields of knowledge such as physics, mathematics, astronomy, chemistry, and different branches of engineering. Okay, next. Euclid, like Archimedes and Apollonius, perfected the process of mathematical demonstration as a chain argument in such a significant way that today its use in modern mathematics is indispensable. Now, as to axiomatic methods, the axioms posed by Euclid in his work Elements pose a global perspective of the axiom that motivated the development of this fundamental area of modern mathematics. Okay, so at this point, let's have his first postulate. So the first postulate states that a straight line can be drawn from any one point to another point. In other references, it is stated as a straight line segment can be drawn joining any 2 points. So as illustrated, for every point P and for every point Q not equal to P, there exists a unique line L that passes through P and Q. So the first postulate implies that 2 points determine a line. So in the illustration given, again we have points P and Q, and those are points that lie on the same line, which is line L. In the second postulate, a terminated line can be further produced indefinitely, or in other words, any straight line segment can be extended indefinitely in a straight line. Now, given 2 points A and B, the segment AB is the set whose members are the points A and B, and all points that lie on the line A or line AB and are between A and B as illustrated on figure 1.2. Now, the two given points A and B are called the endpoints of the segment AB. So we knew that a segment is defined as a part of a line in which it has two endpoints. So on the given illustration, we have A and B as the endpoints of segment AB. And based on the second postulate, it can be extended indefinitely on both sides. And that produces a straight line. And that will be called AB. So as illustrated, the line ends with arrowheads at both ends. So that indicates that the line, okay, can be extended indefinitely on both ends. Okay, so Euclid's postulate number 3 states that a circle can be drawn with any center and any radius. In other version, it states that given any straight line segment, a circle can be drawn having the segment as radius and one endpoint as center. Now, for every point A and every point B not equal to A, there exists a circle with center A and radius AB. So we have the illustration, segment AB, so that represents the radius of the circle, then considering A as the center of the circle. So we have produced a circle out of the given segment as the radius, which is segment AB, and the center at point A. So if we're going to define radius formally, so it is a segment that passes through the center and any point on the circle. Okay, so the fourth postulate of Euclid states that all right angles are equal to one another. Now, based from the other version, it is stated that all right angles are congruent. In the definition of right angle, it is clear that two angles at the foot of a perpendicular, such as angles ACD and BCD, are equal. So that is being illustrated, okay, on the first figure. This postulate says that an angle at the foot of one perpendicular, such as angle ACD, equals an angle at the foot of any other perpendicular, such as angle EGH. So we have here two sets of perpendicular lines, in which on the first figure, okay, segment AB is perpendicular to segment DC, and on the second figure, we have segment EF is perpendicular to HG. So both sets of perpendicular lines generates right angles, and these right angles are said to be congruent. Okay, so moreover, an angle BAD is a right angle if it has a supplementary angle to which it is congruent. So as illustrated, we have line BC is perpendicular with line DA, and that forms two right angles, namely angle BAD and angle CAD. So based on the statement mentioned a while ago, an angle is said to be right if it has a supplementary angle. So if we will be considering angle BAD, so its supplementary angle is angle CAD. We knew that supplementary angles are angles having the sum of 180 degrees in terms of its measure. Now let's have the last postulate of Euclid. It is stated that if a straight line falling on two other straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on the side on which the sum of angles is less than two right angles. So in other version, it is stated that if two lines are drawn which intersect a third in such a way that the sum of the inner angles on one side is less than two right angles, then the two lines inevitably must intersect each other on that side if extended far enough. Now this postulate is equivalent to what is known as the parallel postulate. Okay, so on the given illustration, we have the two lines M and L, in which another line falls on those two lines, and that is line T, and their intersections form angles which are less than 90 degrees, and that pertains to angle alpha and angle beta, which are said to be angles or interior angles less than 90 degrees. So if the two lines M and L are extended indefinitely, so these two lines will meet at a certain point. Okay, so here is the other version of Euclid's postulate 5. So for every line L and for every point P that does not lie on L, there exists a unique line M through P that is parallel to line L. Okay, so that is being illustrated here on the slide, in which we have the given point P and line L, and passing through point P we have line M, and that is parallel to line L. So that is the reason why, okay, it is called the parallel postulate. Okay, so at this juncture we are done discussing the Euclid's 5 postulates. So let's have some practice exercises. So for number 1, which of the following statements are true and which are false? Then give the reasons for your answers. Okay, so we have here 5 statements in which we're going to identify whether it is true or false. Okay, so for the second item, give a definition for each of the following terms. Are there other terms that need to be defined first? And what are they and how might you define them? So what are the terms to be defined? So that includes parallel lines, perpendicular lines, line segment, radius of a circle, and square. And for number 3, consider 2 postulates given below. So the first postulate states that given any 2 distinct points A and B, there exists a third point C which is in between A and B. Then the second postulate states that there exists at least 3 points that are not on the same line. Now, here are the questions to be answered. Do these postulates contain any undefined terms? Are these postulates consistent? Do they follow from Euclid's postulates? Then explain why. Okay, so let's have the answers to practice exercise 1. So on the first item, the answer is false. There can be infinite number of lines that can be drawn through a single point. So hence, the statement mentioned is false. So this was being illustrated on the first postulate of Euclid. Next, for the second item, the answer is also false. Since through two distinct points, there can be only one line that can be drawn. So hence, the statement mentioned is false. Again, this is in line with the first postulate of Euclid. Then number 3, the answer is true. Why? A line that is terminated can be indefinitely produced on both sides, as a line can be extended on both its sides infinitely. So hence the statement mentioned is true. Then lastly, again, the answer is true. So the radii of 2 circles are equal when the 2 circles are equal. So the circumference and the center of both the circles coincide, and thus the radius of the 2 circles should be equal. So hence the statement mentioned is true. Okay, so this in line with the third postulate of Euclid. Okay, so regarding your answers on practice exercise 2 and 3, you may chat it on the comment section and I will be checking it soon. So that ends my presentation. Thank you for listening. So, Diyos mabalos sa inyong gabos.